Measures of position and outliers, Part 1. Lesson objectives: determine and interpret z-scores, interpret percentiles, determine and interpret quartiles. Lesson objective number 1. A z-score represents the distance that a data value is from the mean in terms of the number of standard deviations. It is obtained by subtracting the mean from the data value and dividing this result by the standard deviation. Here's the formula for both population z-score and sample z-score. You take your x value, you subtract the mean, and divide it by the standard deviation. The z-score is unitless. It has a mean of 0 and a standard deviation of 1. These three bell-shaped distributions all have different means and different standard deviations. What the z-score allows us to do is to compare these different distributions, because the z-score will standardize it into a distribution that has a mean of 0 and a standard deviation of 1. So we can compare different bell-shaped distributions by using the z-score. Let's look at an example. The mean height of males 20 years or older is 69.1 inches with a standard deviation of 2.8 inches. The mean height for females is 63.7 inches with a standard deviation of 2.7 inches. This is the notation for bell-shaped distributions. The N stands for a normal distribution. So a bell-shaped distribution, sometimes called a normal distribution. We only need the mean and standard deviation. So for in this case, this is for men, it's normal, bell-shaped, with the mean is 69.1 and a standard deviation of 2.8. For females, it's a normal distribution, bell-shaped, with a mean of 63.7 and a standard deviation a little bit smaller of 2.7. Let's look at an example. Shaquille O'Neal is 7'1". Candace Parker is 6'4". Who is relatively taller? Now, in order to answer this question, since they have different means and different standard deviations, we would compute Shaquille O'Neal's height, 7'1", and Candace's height, 6'4", into z-scores, and then compare them. Shaquille O'Neal is 7'1", so that means he is 85 inches. 7 times 12 is 84, plus 1 is 85. So the z-score is the x value, 85, subtract the mean, 69.1, divided by the standard deviation. We get a z-score of 5.68. Now this means that his height is 5.68 standard deviations above the mean. Candace's height is 6'4", so if we take 6 times 12 and add 4, we get 76. Subtract the mean and divide it by the standard deviation, 2.7. We get a z-score of 4.56. So this means that she is 4.56 standard deviations above the mean. Because O'Neal's z-score is larger than Candace's z-score, he is relatively taller. Lesson objective number 2. The K percentile denoted a capital P with a subscript of K of a data set is a value such that the K percent of the observations are less than or equal to the value. Now that sounds complicated, but really it's not. But this is a visual. Here we have a data set, and this is the first percentile. So this value here separates the bottom 1% from the top 99%. This value here is the second percentile, so this separates the bottom 2% from the top 98%. If we looked at the 98th percentile, this score separates the bottom 98% from the top 2%, and the 99th percentile separates the bottom 99% from the top 1%. Let's look at an example. The GRE is a test required for admissions in many U.S. graduate schools. The University of Pittsburgh Graduate School of Public Health requires a GRE score of no less than the 70th percentile for admissions in their Humans Genetics MPH or MS program. Interpret this admissions requirement. A 70th percentile is a score such that 70% of the individuals who took the exam scored worse. and 30% of the individuals score better. In order to be admitted into this program, an applicant must score as high or higher than 70% of the people who take the GRE. So to put this in another way, the individual score must be in the top 30%. Lesson objective number 3. Quartiles divide the dataset into force or 4 equal parts. The first quartile, denoted Q1, divides the bottom 25% from the top 75%. Therefore, the first quartile is equivalent to the 25th percentile. The second quartile separates the bottom 50% of the data from the top 50%. So the second quartile is equivalent to the 50th percentile, and that is also equivalent to the median. And lastly, the third quartile divides the bottom 75% of the data from the top 25%. So the third quartile is equivalent to the 75th percentile. Here's a visual. Here we have Q1, Q2, which is also the median, Q3. So Q3, here's the bottom 75%, the top 25%. Q1, the bottom 25%, the top 75%. And then we have Q2, or the median. This value separates the bottom 50% from the top 50%. Here's the rules for finding quartiles by hand. First step, you have to arrange the data from smallest to largest. Second step, you find the median. Third step, to get Q1, it will be the median of the bottom half, and Q3 will be the median of the top half. Let's look at an example. A group of BYU students collected data on the speeds of vehicles traveling through a construction zone on the state highway, where the posted speed was 25 miles per hour. The recorded speeds of 14 randomly selected vehicles is given below. Find and interpret the quartiles for the speed in this construction zone. Okay, our first step is we have to put them in ascending order. That's already done. Second step, find the median. Since there's 14 observations, the median is going to be the mean between the 7th and the 8th observation. Therefore, the median is 32.5. Third step, the median of the bottom half of the data will be our first quartile. This is the bottom half. 28 will be our median for the bottom half. 3 below and 3 above. So Q1 is 28. To find Q3, we take the median of the top half, and that will be Q3, which turns out to be 38. Let's interpret this. 25% of the speeders are less than or equal to the first quartile, which is 28 miles an hour, and 75% of speeds are greater than 28 miles per hour. For the median, 50% of the speeders are less than or equal to 32.5 miles per hour, and 50% of the speeds were greater than 32.5 miles per hour. And lastly, 75% of the speeds are less than or equal to the third quartile, 38 miles per hour. 25% of the speeds are greater than 38 miles per hour. Okay, let's do an example using Minitab and StatCrunch to compute quartiles. The raw data that we're going to use is the student ages who completed the student survey during the early fall term 2009. Here's the raw data. To compute this in Minitab, you go to Stat, Basic Statistics, and choose Display Descriptive Statistics. This window comes up. Select your variable and hit OK. In the session window, we see Q1, we see Q2, the median, and Q3. So in this case, Q1 is 20, the median is 23, and Q3 is 29. In StatCrunch, we go to Stat, Summary Stats, and we choose Columns. Select your variable and hit Calculate. Here's Q1, there's Q2, the median, and Q3. Now here's a small little note. When completing your online homework, please use StatCrunch to compute the quartiles, as for small data sets, Minitab computes them differently than StatCrunch, and this may lead to answers that are counted wrong by Course Compass. Now on a test or quiz, you can use Minitab or StatCrunch. That choice is up to you. Thanks for watching.